So, hello, good morning. Thank you for being here. Thank you, Ludovic, for being here and giving our talk. Before we welcome our speaker to the next talk of today, I would like to thank the sponsor of the room, which is ActiveState. ActiveState empowers innovation from code to cloud, smarter, safer, and smarter. Built with and on top of various open source packages, including Cloud Foundry and Docker, SCaLE is ActiveState's groundbreaking application platform for creating a private platform as a service. For more information, please see activestate.com or visit their booth down at the expo floor, booth 83. So the talk of today is about VideoLAN and VLC and its distribution application. As we probably all know, VLC Media Player is a universal open source cross-platform media playback and streaming application. The talk will start with an overview of the VideoLAN project and its community, the modular architecture of VLC, and how one of the most downloaded software in the world is distributed while keeping costs low and reliability high. So, I would also like to remind you to please fill out the talk feedback survey and the feedback for the presenter and the presentation after the talk. So thank you, and let's welcome Ludovic for the talk.
Thank you. So hi everybody. I'm really glad to be here at SCaLE to do this presentation, which is about VLC, which is well-known open source software. So I'm Ludovic. I came especially from Paris. I'm part of the VLC development team since 2008 now. I started in 2008 by building VLMC, which is a nonlinear, video editor. That was my student project. So I started in 2008. Now I'm the VideoLAN treasurer, and I'm founder of a company called VideoLabs SS, which is based in France, and do support and development around VLC. I'm also the main developer of MirrorBit, which is going to be the third part of this talk. So first, I'm going to talk about VideoLAN, who we are, what we do, and etc. Then I'm going to talk about VLC, what you know about VLC and what you don't know about VLC, and finally I'm going to talk about MirrorBit. So VideoLAN is a non-profit, as you may know. So VideoLAN is only made of volunteers. This is where everything started at École Centrale Paris, which is an engineering school in the south of Paris. You can see the student rooms on the right, because this is important for the rest of the talk. I wasn't there. I wasn't at this school, so I can't tell you much about it, but this is where it all started. It's the south of Paris. I mean, it's 20 kilometers from Paris, in the south. It's not in Paris, yes. Everything started in a campus student association called VIA, Central Réseau. At the time, they had a slow internet access through Renata, and they were using a token ring network, which is quite special, but was common back in the days. So they were desperately in need of a new network. They wanted Ethernet badly. So what they did is they asked the school, and the school said, "We are not going to pay for it," which is quite common. And so how to justify the need for a new network? And then at the time, Bouygues, which is a well-known company in France because they own the main TV channel and few other stuff, they said, "Okay, guys, if you are able to saturate the network by doing something interesting, a project, we're going to buy you a new network." This is where it all started. So they were thinking, and they said, in 1995, let's do video streaming. So they decided to create an MPEG-2 encoder-decoder to be able to stream the TV channels on the rooms of the students. So this is where all started. So in 95, 96, they started to work on an MPEG-2 decoder. They knew nothing at the beginning about how this whole thing was working. So it took 2 years to complete, so having an encoder and decoder. And then they decided in 98 to reboot the project because the code was crap and it was barely working. I mean, it was crashing after 20 seconds of videos and so on. But they learned a lot. So they decided in 98 to rewrite everything and to make it open source, to make it modular, because they've seen that MPEG-2 was not the only codecs around. Cross-platform, that was for the challenge, because they were using Linux only, so they wanted to port it to different OSs. And of course, network-oriented, because what they wanted with the Ethernet network was to do multicast on the student room. And as well, it became a student project. So every student of the school could just join the project and earn some points for their graduations. And in 2001, they had the agreement from the École Centrale Paris headmaster to be able to relicense the project, because the school didn't want at first a relicense, because they've seen that they can earn probably a lot of money out of this project. So in 2001, it became under the GPL v2 or later. So in 2001 and 2002, that was the advent of peer-to-peer video, because the connections were faster at the time. So people started to exchange videos a lot. And we had networks like eDonkey and Casa, and playback of incompleted files were something that was interesting, because there was a lot of videos which were not what they should be. I mean, if some of you remember, if you downloaded some video from DivX or something similar, you might end up with porn and so on. So VLC was known for being able to play all the codecs and all the videos which were incompleted. So that was cool, and that was because VLC, already in 2001, did not had any specs about codecs. So they reverse engineered, and where original codecs were not able to read uncompleted files, VLC was able to do it. And it was codec pandemonium as well, because you had codec packs everywhere with viruses, toolbars, and so on. And so VLC became really popular in 2001. VideoLAN today is a French non-profit, so it's an association. It was created in 2009, so pretty recently, and is dedicated to support free and open source software and multimedia. Today we have 28 members, which are all volunteers, mostly core developers and important members for the community. We only survive with donations. We don't have anything else to get money, and that pays for hardware, of course, service, travel. Like, I'm here today because of all the donations, so thanks to our donators. Legal, and of course the VideoLAN Dev Days, which is our annual meeting that we do usually in Paris. Last year we did it in Dublin, where we try to make all the people from the community join us. And that means not only the VideoLAN and VLC developers, but side projects, because VLC depends on a lot of libraries, and we try to make all these people come to VideoLAN Dev Days and share their experience. Today on VideoLAN there is like 15 projects alive, because they had a lot. And here you have the list. So for example, libDVD CSS, which is well known for DVD CSS decryption, is part of VideoLAN. The famous X264 encoder, which is also part of VideoLAN. libBlu-ray and libASS for Blu-ray playback, and the new X265 HEVC codec. So that was us in 2013 in Paris at 3 headquarters. That's mostly, we have like 15 developers and the rest are part of the community or developers for other projects. And that was us last year on top of the Google Dublin building. So, how does team work at VideoLAN? We have at least 2 meetings each year. We have 4 meetings, 2 small and 2 big ones. For the big one, it's the first day in February in Belgium, where we all meet, and the VideoLAN Dev Days, of course. And the location depends because we are trying to move away from Paris. And we were one of the first big projects to use Git. So it was in 2007. It was really painful, to be honest, but no, we are used to it. IRC and mailing lists are mainly used. It's our main channel for developer communication. Everything is public, so you can read and you can exchange with us through these channels. We use Track mostly for bug reports, PHPBB for user support, and MediaWiki for the documentation. And we have simple rules, the main one being the one who code has power. The more you code, the more power you have in the decision-making process. And pretty recently, we had to introduce a code of conduct, which is a bit sad because we had people fighting in the community, so that's it. Decision-making, VLC contributors. The core team is composed of 5 to 10 people. That's not a lot. We have around 4 developers that commit each week. That's really small for a big project like VLC. We have around 150 different committers each year, and 600 in total since the beginning of VLC. So the decision making, it should be maintainable. That's obvious, but a lot of people tend to leave the project once they drop their patch. Like, hey, this is a feature, it's big, it's huge, and I'm not going to maintain it, deal with it. So it should be maintainable by all the people actually working for VLC. It should be technically standard compliant like most open source projects. We don't like memleak and other bugs, so we tend to try to make it clean. We don't care about marketing and legal when we add a functionality. Basically, even if your feature is not used by anyone and will not be used in the future, I mean, if it works and if the code is okay, then it's going to be merged. We don't take any decision based on legal or marketing. And of course, code is power. The more you code, the more power you have in the project. And that's one of the main rules that drive the community. And consensus or fork, that means either we achieve a consensus in the community, in the core developers, or we just say, go and fork the project. But surprisingly, we don't have much fork, so things are just working. And to do releases, of course, we use Git, and we usually create branches to create new features and merge it back into the tree. And we maintain 3 main branches, which is the master, which is the development branch. We have the current stable branch, where we apply only bug fix, and we have the previous stable, where we only do security bug fixing. So welcome in the multimedia wonderland. It's just awesome, you'll see. But there are a few rules that you must know before entering this awesome world. And the first rule is, in multimedia, if there is a stupid way to do something, someone will do it that way and complain until it's a standard and supported. The second rule is, in multimedia, everyone thinks he understands everything, but actually no one does. And that's really true. And the main problem we have in multimedia is the not invented here syndrome. So you may know this comic from SCaLE, where you have the first situation with 14 competing standards, and the guy said, hey, ridiculous, 14, we need to develop one universal standard that covers everyone's use cases. And the girl said, yeah. Soon the situation is that you end up with 15 competing standards. So, speaking about containers, containers are almost varying between complete crap to somehow broken. Except MP4 and MKV, which are the cool guys in town, they just works. The worst are AVI, FLV, and OGG. Speaking about codecs, many, if not all, have bad designs. Most have bad encoding. Sometimes some of them are really slow, and the output is sometimes not good enough. They are made to work for some containers, but doesn't fit in them, so wrong containers. And at the end of the day, you have too many codecs and profiles, and you just can't make it work. So multimedia in free and open source software are widely used by video experts, of course, and professionals doing broadcast. We have a lot of TV channels and broadcasters that are using VLC at some point. There are numerous projects, there are a lot of projects which are open source about multimedia, but a lot have abandoned, just dead, are difficult to use. I mean, that's incredible. We have a lot of projects, but they are inusable because they are too complicated. You have to be an expert to use them. And sometimes the usage is restricted because of patents, and that's a problem. So let's talk about VLC, also known as the cone. And you may wonder why VLC icon is a cone. At VIA Centralizo, so the association in the campus, the group who started the project, they were collecting traffic road signs. And so they decided, when they were in need of a new icon, to use a traffic cone. That was obvious. And they were thinking at the time that they may change that icon once the project is stable enough. But now it's still there, and people recognize VLC because of the cone. So VLC Media Player, it is widely known because of its support for DVD. And since we never had the spec for the DVD, you can pass the ads, you can pass the commercials, you can pass the forced subtitles, and you can play any DVD, even if it didn't come from your region. You can buy DVD in the US and play it in Europe, and that was so cool at the time. Blu-rays, of course, by default only unencrypted ones. But if you search on Google, you'll find how to play encrypted one. Network streams, of course, unicast, multicast, and adaptive streaming, which is quite new, and is already working in VLC. And external hardware, cameras, TV input, SDI, you name it. And of course, plays everything everywhere. And that's the everything, and that should be the everywhere. So VLC today, it's 1 million downloads per day. Yeah?
Does this mean I can put my USB tuner, TV tuner in and hook that up with
Yeah, absolutely. VLC do that.
Does it record?
You can record with VLC, yeah. Yeah, you can do all this stuff. So VLC is 1 million downloads per day now. So it's quite huge for an open source project. We have more than 2 billion downloads in the early days that we were able to count, but that doesn't count all the Linux installations and Android and iOS. That's just for the desktop version. And that represents between 150 million users worldwide, which is huge. We're on 1 Mac out of 6. We're in the top 15 on Windows, all countries, and it's the French most used software. So what makes VLC so good? It's not because of the marketing. We don't have any marketing. It's most likely because it just works. So how does it work? That's the business logic of VLC. You have the access on the upper left. So that's the model that is able to access the resources, HTTP, Samba, SFTP, or just a plain file. Then it passes the data to the demux, which opens the containers, Containers is like MKV, MP4, AVI, and split it in elementary streams. So it extracts videos, audios, and subtitles track. Then it passes it to the decoder, and the decoder is, for example, H.264 for the video or Opus for the audio, which actually decode the streams and send them through the filters, and finally feed the output that can be either displayed or just re-encoded to be streamed back. That's basically the business logic of VLC, and which makes it so modular and so powerful, because you can just drop a new module inside VLC and it will change all the modules together. So you don't have to know anything about the other levels. You can, if you're good at writing sockets, you can just create an access, and you don't need to care about videos and decoding stuff. So in VLC, you have two main parts in the core of VLC. You have the VLC core, which is really small and light. It's like a few kilobytes, and that's the core of VLC. It's in charge of all the memory, network, and thread handling. Is in charge of loading all the modules and manage the clock and the synchronization. And what's funny is that VLC, you can launch it without any modules, and it will just plain crash, because the core isn't able to do anything by its own. Even the logger is a module. So you can remove all the modules and start VLC, and it's going just to crash because it has nothing to do. And you have libVLC, which is the public API that is used by external software, external applications, which is a complete multimedia framework written in C with a quite simple C API. And you have bindings, of course, for a lot of languages, even Node.js. So that's another view of VLC. You have in the center of libVLC core, where all the modules are plugged in. And you have libVLC, which is the C API, and all the applications using it, like VLC or VLMC, and of course many others. So speaking about libVLC, you can do a lot of stuff with it. Playback, filters, controls, streaming, quite limited though. You can build a DVD ripper if you want to, for example, and we have a thumbnailer in it. And that is used by all the mobile version of VLC. So if you're using VLC on Android or iOS or Windows RT, we're using libVLC. So you can see what we can do with this API. It is also used by the KDU team for Phono, which is their sound layer, and many more. We have service discovery. That means we are able on any network like UPnP DLNA or Samba to discover all the files. If you have a DLNA server at home or Samba, you can just launch VLC and explore everything. It also works with internet services. Maybe you don't know that you can just copy and paste a YouTube URL inside VLC, and it's going to play it. Without the wait page, without the ads, just going to play it. And that's for YouTube, Dailymotion, Vimeo. We have plenty of them, like dozens of them. And it's, of course, highly customizable. We have plugins in Lua, and you can publish them on addons.videolan.org or download them. So that makes VLC really extendable. What you don't know about VLC, or maybe you do, but you can do transcoding, streaming. You can do TS encryption and decryption. That's mainly used for broadcasters. You can rip DVDs and CDs. There is a headless version, so most people here are using Linux, but you can run VLC on a server without having any UI at all. There is a karaoke and MIDI extensions, so you have the subtitles that are written like in any karaoke. Hardware decoding on most platforms, including mobiles. And web interface, so you can even stream your own content from your VLC at home to anywhere in the world. But that's really not known by many people. And this web interface is used by most remote control that you can find on Android or iOS. But that's not all. You can do screencasting with VLC. That's quite funny. You can have a mosaic. So that was a mosaic that was used in France in a French ISP called Free. They used this mosaic to show all the TV channels at once, and they were using VLC.
France 24?
Sorry?
France 24, is that part of the company?
No. No, that's only a mosaic for French ISP. Yeah. And you can do picture-in-picture with even with alpha channel. You can do wall if you have lots of screens. You can do you can split the video in how many parts you want and do it on a big wall screen. And of course, the most useful feature ever, the ASCII output. That's quite nice. You can stream your own video in a terminal and play it back remotely with a very small connection. So what's new in VLC 2.2? So this version is going to be released really soon, but first we're going to talk about the last one, the current stable, which was called Rincewind and was released in October 2013. We started with the version 2.1.0 and we ended with the 2.1.5, which is currently available on the website. We had more than 420 million downloads of this version of VLC. It was stable, but we had some regressions on some formats that are going to be fixed in the new 2.2, which is called Weatherwax. Lots of commits, as you can see. It took 1.5 years to release. So it's a very strong release because we wanted to release it last December, but we lost all of our servers. So we weren't able to do any release because they all broke. We had like 4 servers that were very old, and we used it to do the billboard, the compilation, and so on. And in December, 2 days before the expected release date, we lost half of these servers. So we had to buy new ones, deploy the new ones, and this is why it took so much time to release. But now this version is really stable. And there are lots of new improvements, like the video rotation. That was a feature requested by Linus Torvalds, because on a Google Plus post, he made a rant against VLC because his children was filming in not the proper way, and VLC was not able to rotate that video because in the container you have the orientation, and we didn't manage that. So we did it. We told Linus. He was very happy. So the detection works in MP4, MKV, and H.264. And so the auto rotation works by just asking the video output if it is able to do the rotation in hardware. And this works with Direct3D, OpenGL, and Android. Else, we fall back on software rotation. We have an extension manager. So the design is not the end design, but it's pretty much like what you have in Firefox. So you can now directly download extensions from VLC. We have a lot of extensions to grab automatically the subtitles. Like when you're downloading something, you just make a hash of the file, and then it's going to find the proper subtitle. So you can just look at all the modules and just install it, and you're done. We have the resuming, so you can play back where you left off. That was a requested feature for a long time. Speaking about codecs, we added support of HEVC, VP9, and Opus in MKV, TS, and MP4 containers. We added partial support of BDG, which is the Java virtual machine for Blu-rays, to improve and to add some interactivity in Blu-rays. FTPS support. I don't know who is using FTPS still today. DCP, mostly for movie theaters, and a lot of weird codecs. MSN audio. Who's using that? I mean, We have, yeah, plenty of new codecs. But the best one are PIX, FFV1, VP8org, and WebVTT. So we added GPU zero copy as well, because the old way of doing things, we were copying frames each time. So memcopy is bad, and it takes a lot of CPU and time. So what we did originally was take a picture, decode it in the CPU, send it to the GPU, get it back in the CPU to add the subtitles and all the frames that we needed to add on top of the video, and then send it back to the GPU for displaying. The new way of doing that is we created a fake format inside VLC, and now all the decoding and displaying will be done on the GPU. So we're gonna have better performances. And this support was added for VDPIU media codec, that's Android and Raspberry Pi, because yes, VLC runs well on the Raspberry Pi. We have also mobile versions. We are probably going to do a synchronized release for iOS, Android, and WinRT. So some of you may wonder if the iOS version is going to be back. So the answer is yes. It is already back if you have downloaded VLC in the past. You can go to your App Store and just download it again, and it will be the new version. For the others, it's going to take a few more days because we had troubles with Apple. The first 1.0.0 version for Android is going to be released too, and they all use the newly VLC 2.2. And of course, WinRT and Windows Phone, which are going to be released anytime now. So for the 3.0.0, we have a lot of new things that are going to be added. HDS dash smooth streaming mostly, because this is required today. That's the new way of getting your streams. So definitely we are going to improve that. We will have VLAN support, GPU zero copy on Android, ARIP subtitles, HEVC, VP9 hardware decoding. That will be on Android and maybe on some iOS devices. And we did a large rework already on MP4 and TS demuxers. They have been completely reviewed in the last year. And this is going to end up in the 3.0 release. And SMB, Samba, and SD browsing, which was a feature that was requested for a long time. So now you will be able to browse all your files on SMB directly from VLC. So now let's talk about mirror bits. So this is a project I started 1 year ago, almost, because we had the need at VLC to be able to distribute VLC without issues, because in the past we had some issues. We started with only a bunch of mirrors, and we had a random, basically, to distribute the clients and the download request on each of them. But since VLC is now millions of downloads per day, we had no other choice than developing our own solution to make it work with all of our mirrors. And today we have like 60 mirrors or 70 mirrors, which is a lot, all over the globe. So the VLC distribution dilemma was it must be cheap because we have no money. We are not going to pay for servers everywhere in the world. So it must be reliable because people expect to be able to download VLC when they are coming to the website. It must scale. That's really important because we have 1 million EJ, but during our release and when we are launching auto updates, then every time you launch VLC, you're going to have a pop-up saying, hey, you should update, and that's worldwide. So we can jump to more than 4 million downloads on a day, so it must scale. That's important. And it should be geographic close because of the latencies, and supposedly you get faster downloads as well. And as a bonus, if we can get statistics, that's awesome. So mirrors, that's not something new. Most open source projects uses mirrors. Basically, what we all have is an AirSync server, and they provide HTTP or FTP to make the download. But sometimes, and more often than not, it's the user job to select the mirror. So they have a list with countries, and they have to click on it, and they don't know if the mirror is working or not, if it's up to date or not. They just select one, pick one, and maybe they can even pick the same, and it's going to be bad for the mirror because the mirror will not be able to catch up with the load. So on the pros, it's cheap and simple. You don't have anything to do. You just have to have sponsors that give you mirrors and synchronize your own mirror. On the cons, it's not reliable. If it's down, you don't know it. And it doesn't scale. If everyone goes to the same mirror, then your mirror is screwed. So MirrorBits works on the exactly same architecture. You don't have to change anything. You have all your mirrors, which are providing AirSync, HTTP, and or FTP. So it's a geographic load balancer. So it works on top of existing infrastructure, so you don't have to change anything, just have one server. And it does, what it simply does is do HTTP redirects. So depending on the client that came and asked a file, it will just find the closest mirror for you, which is serving that file, and it's going to redirect you to the good mirror. So it is smart because it knows which file is served by which mirror. So that allows you to have mirrors that have only partial files on them, that are hosting only a few of the files, not all of them, because the VideoLAN AirSync server is like 30 gigabytes, which is quite huge. So you can have mirrors that are just mirroring VLC and the latest release. And MirrorBits takes care of just knowing which file served by which mirror and not going to redirect you on a mirror that doesn't handle it. It also monitors the state up and down. So if a mirror is down, obviously it's not going to redirect there, but it's going to monitor it until it comes back. It avoids hotspots because we had a lot of issues in the past where we do not have, for example, mirrors in India, and there are a lot of users in India. And what happened is that all the download requests ended up on the closest mirror, which was, I don't know in which country, but that mirror was down every day. I mean, they were like getting millions of requests each day, and they were getting down. So MirrorBits avoid hotspots or tries to avoid them. So if one mirror gets too many requests, it's going to be redirected on the closest mirrors. And it does checksum, of course, if possible, using AirSync and by checking few files randomly on the HTTP interface. And one new and nice feature is that you can get download stats in real time. So that's pretty cool. So that's basically how it works. You get one request, for example, that comes in. MirrorBits is going to check where the request came from, and will redirect it on one of the mirrors, which is available, not overloaded, and still closed. You get a second request, it's going to be sent to another mirror, for example. Then other requests that are going to another mirror with a bigger bandwidth, for example. But still you have one mirror down. And as soon as that mirror goes up, it's going to receive requests back again. So MirrorBits is written in Go because they wanted to try that languages. And it's pretty funny to do. It has very good performances. I was able to achieve like 8,000 requests on my laptop, which is quite good, considering that we have a lot of stuff to do because each request is unique. You cannot cache the result, of course. So you have to compile a lot of stuff, and when you have 60 mirrors, that's quite huge since you have to get the IP address, resort that to a GPS position, and then compare it to the list of your mirrors, which have the files and which are up. So that's pretty cool. It works on top of a Redis backend. So that should be clusterizable. I have reports from people using Mirrorbit that they were able to clusterize it. So basically, you can have multiple Mirrorbits running in parallel and improve your throughput. Of course, it's open source, licensed in the MIT license, and it's available on GitHub. So I'm going to show you a few screenshots, or even better, if I can, the real version. Okay. Let's try that. So here, oops. Okay, so here you have the mirror stats. So you can see in a very simple way all your mirrors and their state. So everything is green right now because we are going to release the new version of VLC, so I had to ensure that all the mirrors were available. And basically you can just zoom in and check all the mirrors that we have for VLC, for example. Let's try in the US, for example. The closest one here should be this one, OS 6. And you can see in one simple way the state of all your mirrors. If we're going down, you can see the number of downloads today on each mirror and the estimated bandwidth that was used for each of these mirrors. And so we can go down, 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 down until we have mirrors that are down or not available. So this is the page. I'm going to move that away. Okay, that's the page of the mirror stats. That's a page you can request for each file that you are serving through Mirrorbit. So you can see the list of the mirrors which are around and the probability of them getting selected. This is to avoid hotspots. So you have more chances to get this one than any of the others, but still some requests might be redirected on other mirrors around. So since we are in the US, as you can see, California, we're getting on this server. And here you have the list with the probability of getting the request coming to this mirror. And if we refresh the page, it's going to change. So here you can get the distance between you and that mirror, and few other information like the file size and the file hash. Oops. So who is using Mirrorbit in production today? VideoLAN, of course, for serving VLC and all the other projects from the organization. We have SuperRepo, which is an XBMC Kodi add-ons repository, which is using it since last summer. And pretty recently, we've learned that PopCompTime is using it to distribute all their updates. And maybe you know, if you have an open source project and it's big enough that you need mirrors, or if you work in a distribution, I mean, you can use Mirrorbit, and it's going to improve the way people will feel the downloads from your project. And I have a pretty good news since we had a new achievement of 250 million downloads handled by Mirrorbit yesterday. So it's been less than a year that we've put it in production, and already it did that just on the VideoLAN infrastructure. So thanks a lot. Do you have any questions?
How do you make sure better keep systems not overloaded?
Sorry?
Not overloaded with request. Do you have multiple
Yes.
instances running?
So the question was, how do we ensure that Mirrorbit is not overloaded by request, and because it's a single point of failure? That was the question. I'm currently working on improving that side, because today you can have two Mirrorbits with different databases that can work in parallel. That works, and we use it at VideoLAN. But what I'm going to do is I plan to make it work with the same single databases, with Redis databases in cluster, so you can share the information between all the instances. So this is already a work in progress, and it's going to be released soon. The next version, probably, yeah. Any other question? Yes?
Yeah, how do you deal with the legal ramifications of like including a module that skips ads in YouTube, for example? Do you guys have problems with that? Have you had like takedown notices or anything like that?
Yes, so we never had that kind of issues. And since mostly we are based in France, we don't have much troubles. But if this happens sometimes, that we have a request of removing a module, I mean, we will try to do our best to keep it. But if we receive too many threats, then we're going to take it down. Yeah, of course. Yeah.
The same question vis-a-vis regional quoting on DVDs. Seems like Hollywood attorneys.
Yeah. So yes. Yes. But so VLC is in France, is based in France, and we had a special law about DVDs, because at the time, it was in 2001, I guess, we had a law in France that allowed us to be able to decrypt DVDs because to support other systems where you couldn't get any DVDs. For example, Linux, you couldn't have any commercial player. So there was an exception for all open source software to be able to use to decrypt DVDs. And this is also true for Blu-rays. This is why only Blu-ray is giving away with VLC. It's packaged inside VLC, but you don't get the keys because the keys is something different. DVDs had no keys. Blu-rays does have keys, and this is why you cannot play encrypted Blu-rays on VLC.
So I was wondering about audio and video filters, if
Yes.
there's ever been a comparison as to the output from any given filter compared to a commercial version of that filter?
To be honest, the filters we have, not sure we are talking about the same thing, but filters in VLC are mostly a rotation filter, basically to add effects, add text on top of a video. So I'm not sure we can compare that to commercial filters.
Well, maybe audio compression or anything like that, something that's going to change the output in some meaningful way. Maybe if there's a low
pass filter.
Maybe that, or a low volume video, and you bring up the volume in a way that's not going to clip if it gets loud all of a sudden, like compression or dynamic range or anything like that.
We don't have much module like that. We have few of them, but we didn't compare to commercial solutions.
Okay.
So, but because it's open source, I mean, anyone can improve it, and we hope that we have one of the best models for that. Any other question? No? Thank you.
Well, thank you then. Thanks.